hello, it's Crewton Ramone's House of Math. So, I think you guys need some training, but nobody wants to pay for training. That's the fun thing. So anyway, $100 tomorrow, and it seems that people come on the spur of the moment. I try to give you guys advance notice, nobody shows up, but spur of the moment, you guys make it a crackerjack decision. Maybe I should get some training. All right, so I'll do 2 of them because this is advance notice, and or excuse me, this isn't advance notice. It'll be advance notice for next weekend though. So right, tomorrow, we'll say 6 o'clock my time, 6 o'clock Hawaii time, at 6 a.m. If I have even one person paid in advance tonight or tomorrow, I'll do it, and then I'll record it, and then guess what? I'm going to sell it for $100. Right? Days of discounts are over. And then on next Saturday, same thing, 6 to 10, I'll do a training. I was doing some stuff here with the people on the super duper secret math camp group, and getting some questions about doing multiplication, stuff like this. This is just super easy, actually. But if you don't know how to do it, you don't know how to do it. And trying to show you the fast, easy way to count them up, where you count up the big ones first, and then showing them this algorithm, but understanding the concept in just 2-digit multiplication. Okay, so, and Sir will be doing much more than that tomorrow. But like I said, tomorrow, 6 to 10, and then next Saturday, 6 to 10, I'll do 2 of them for $100. If you come to one of them, $100. If you come to both of them, great, $100. And then I'll record them with my camera right here, and we'll charge that. We'll use that to put it on a web page or something, and you can get access to that. And of course, lifetime members will get a super discount. But regular folk that wanted to come to the training, you should come to the training, because there you can ask questions and it's interactive instead of just watching video. I put a much longer video on this over at the super secret math group, and got a little discussion going on underneath there, and I'll do more of that. But anyway, tomorrow, like I said, if I get one person paid, then I'll do 4 hours from 6 to 10. That's Hawaii time. I'm talking about Hawaii time. So it's 9 o'clock in California and noon on the East Coast, and same thing next Saturday. So anyway, if you want to come, $100. If you want to watch the replay, it's still going to be $100, because that's the thing that a lot of people are trying to do. Is like, oh, if he records it, then we'll come and watch it for free or nothing later. No. Okay, so that's there's the scoops, because I see, and some of the questions I see, and I'm flew around on other websites and pages and so forth on not only Facebook, but various forums and so forth. And you got the tools, you just need to learn better how to use them, and make it easy. And as Kirk said, learn about flow and how to just go from one topic to another. But problems like this should be 5-year-olds, and they get to practice. If you do it this way, no, because this is a core algorithm. But if you do it the other way, they're just going to practice their add-ins, right? And have fun. And you'll see me in theory and practice with a little 10-year-old. But I mean, you could just as easily be doing it if it was a 5, 6, 7-year-old. For sure, a 6 or 7-year-old can do these kind of problems. And this is considered "quote unquote" higher level mathematics, right? For little kids, I mean, it's not considered high school math, but I mean, a little kid should be able to do this. I mean, you're a little child once they can build them. And so you don't start here in a big one. We just start with like 100, right? 10 times 10, and then go from there. So I'm going to do just a little bit here on this because I had questions. So we'll talk about this. And so again, I'm not starting here at this big problem. I'm going to start with a small problem. And this is where your multi-tens come in really handy. Really, really handy. So here's just a really quick lesson. 10 by 10, right? That's 100. So if you give a child, look, I've got all kind of pens here to choose from. I think I'll go with one of these. So if you give a child a problem like 12 times 13, actually, let's put it this way. 13 times 12, that's just proper syntax for mathematicians. Does it matter? No, it doesn't matter. But anyway, the top number usually is bigger than the bottom number. All right, and then that, and then that. That's all you're doing. Okay, so the algorithm that you guys know is this. Oops. Is that. Okay, and then I gotta put a line here. And I'll put the 0 in advance. Not an arrow, because there's not gonna be anything there. let's just do 12 times 13. All right, can I do 12 times 13 because I don't have blocks handy? Yes, I do. Oh, yes, I do right here. All right, good. All right, so what do I have to do? What does this thing do? Well, do what it tells you to do. Again, you understand that now I get it too, because it's like this is not, these reflect this, not the other way around. So yes, this tells you what's happening, but what they're doing is, what the blocks are doing is modeling what's happening, and what the symbols are doing is telling you what happened when you were modeling it, not the other way around. So you don't try to make the blocks reflect the symbols, right? The symbols reflect the blocks. Okay, I didn't realize that that wasn't even an issue. All right, so 13 that way, 12 that way. Look how fast this is. I don't have to grab a whole bunch of these units, these single ones, right? And then when we get bigger, we can build add-ins using these guys so that they know that a 3 and a 2 is 5 and so on. All right, and we'll throw 2 guys in like this. Look, 156. I'm done. I just counted it. That's all you're doing. This is what this does, is help you count it. So look, I can't just do this though, because this little snaggle farts will be like, oh, you cheated, right? Because you didn't show your work, because that's basically what this is showing your work. So let's do this right here. Look, can you see what we're going to have there is 2 13ths, literally 26, right? That's right. Oh, but no, you can't do that. You can't do that. You got to do this first. 2 times 3 is 6. And if you had to carry some, then you carry. Anyway, 2 times is, yeah, okay. Now, that's literally what we did. Are there any units here? No. Now what? Well, oh, 130. So in this, how many? 3 of them? 1 of them. See, if I'm a little kid, guys, if I'm 5, 2 in this box, 6 in this box, right? We don't want to spend a lot of time with a pencil when they're 5, but I'm just saying. 3 in this box and 1 in this box. And I know that this is the hundreds place, right? Our place value takes care of itself. All right, so, and then 0 here. All right, that's the way to do it the long way. And then I add these 2 together. I got to add that, right? And then sometimes I can get confused in the carrying and bar. Okay, how do I mirror this with blocks? Split and shift. And you can even, on the board it's hard, but with the, on a table or something, you just put your finger here and even make the sound, right? Make some sound effects there. There you go. Now look, my boxes are where they're supposed to go. Right? Nothing in that box. Right? Okay, that's it. That's how you mirror the other way of doing it. Okay, the way I show kids, and see, once they understand the concept that all we're doing is counting, what do I have? Well, I can just look at this and do this. That's the 100. Then I know 2 10s and 3 10s, 2 10s and 3 10s is 5 10s. Sorry about that. Really? Can't wait. And 6 units. Done. Let's do a bigger one. You guys build. I will draw a little picture. And okay, so and you can see in that hour, I'm not gonna do this with a little child, right? Because I'm just, okay, here, I just got you one problem. We just started off. We started off with this. Usually I'd start with 11 by 11, and then you've seen many lessons that I've done with 11s, because 11s are cool, and you can do lots of fun patterning and so forth with 11s. But that's not the point of this lesson. But see, I could flow right into that lesson if I wanted to from here, but, and you know, just back up. But we're gonna go forward, and we're gonna go bigger, because bigger is funner. So, all right, what should I do? I'm gonna do the blocks that I have here. Actually, you know what? Let's do, what do I have? I'm gonna 7 and an 8. Ooh, it's big now. And you know what? I'm so lazy, I'm not even putting this over there. Okay, so again, I'm not gonna use the block. You use the block. So what I'm gonna do, I'm gonna do 18, 17 times. So fine, I'll put it here. 18, 17 times. I'm gonna draw a picture. 18, 17 times. Ooh, that's a kind of big one. And see, but this is still inside the 20 by 20 matrix. And once these kids understand how to do this, you'll see if you teach your kids from an early age, it'll look like they have these memorized, but what you'll see is them looking up and seeing this picture and then adding everything up. So if you try and do it, quote unquote, my way, it's not my way. This is just base 10 blocks and it's a different algorithm. That's all it is. 100. Well, how many? So I just did that part. 7 10s, 8 more 10s is 15 10s. Uh-oh, so that means I've got 250. And then what goes right there? hopefully they have their single digit multiplication either mostly handled, or they can skip count it, or they can sing a song with sevens, or they can sing a song about eights or whatever, and know that 7 times 8 is 56. All right, so 56, uh-oh. All right, so I'm gonna have a 6 over here, and another 50 makes that a 0 and makes that a 3. 306, check it. That's it. All right, well, get these guys out here. And here's my picture. Oh, terrible picture. Let's try again. Oh. Okay, a little better. But see, all it is going to be that quadratic. See, I'm seeing algebra and all kind of fun stuff in here. All right, that's a little better. Okay, oh wait, now I want to split and shift it. Oh dear. So I'm going to put this over here like this. I'm going to put this one over here like this. All right, now I can count the slow, ridiculous algorithm that they give you and show my work. Because just getting to the answer, that's not good enough. All right, can you see that? There's a terrible glare here, but this is 100. Darn it. All right. This 100 is over here all by itself. Okay, and see, in a minute, I'll do one that has a little bit more and we'll quit. All right, so what's in this box? And I mean, how much is this? Well, if I look at this, this is 7 times 8, that's a 6, right? Okay, wait. So I'm going to do it this way. 56. And then 7 times 1, well, that's not 1, that's a 10, isn't it? Is 70. Oh, look, my add-in. Do I know 7 and 5? That little girl that she forgot what 7 and 5 was, or she for a moment. But okay, so if I take 3 out of that 5, I've got 2 left over. If I take 5 out of that 7, I've got 2 left over. So I'm going to have 126 right there. Correct? This and this. All right, now, what's over here? Nothing. I mean, nothing. Nothing to count. Okay, now, what's over here? Well, the 100 and the 80. Or you can go the other way because they want you to do it that way. Usually, I don't know why they try to get you to do it backwards, but anyway, it's 180. And if you're playing with your block and you got your blocks right there, you can see the 180, and you can see the 126 up here. Okay, now I got to add them. A 6. Oh, we just counted it differently. Nothing there. Carry another one. 306 again. Oh, look, we got it again. Okay, but all we're doing is counting. That's it. Okay, so this is the algorithm everybody knows. But I'm saying there's a faster way to do it where you just keep track of them, count the big ones first. We can also look at it like this. And a lot of little kids find this, my sons in particular, find this to be good. Base x, let's go to base x. X plus 8 times x plus 7. All you do is flip your blocks over. All right, so look, I'm flowing in algebra. I can start doing algebra and factoring polynomials. This is why I spend so much time with kids, factoring polynomials and playing with the algebra and so forth, so that they get the generic math. Well, what do I get? I get an x squared. I hope you can do it. It's 7x and 8x. Notice I'm not foiling. I'm looking at a picture in my mind, actually, that same picture, but you can make up a method for doing it. But 8x and 7x is 15x. And then over here, 8 times 7, again, is 56. All right, so what do I have? I have 100, 150, and 56. And when I add that all together, I get 200, I get 306. That's why you can go this way instead of going this way. How do we read, right? How do they do math? Oops. And they put all kind of cute little things in there to confuse you because mathematics is your gateway subject. All right, let's get bigger. But you see, guys, this is easy. We want the concept of it, right? The nitty-gritty of it and doing worksheet after worksheet after worksheet with 2-digit multiplication, that's not going to be effective. But understanding what's going on, that is effective. So, spot. Okay, the point of this whole thing is, look, you want training like this? You're getting some for free. You want 4 hours of it? Tomorrow, $100, 6 to 10. Right here, right now. Well, okay, not here. I'll put a Google link up. And, you know, if you send me PayPal and so forth, I'll send you the link and enter the email. Or anyway, we'll get it together. It won't be a problem. It will be on Crewton Ramone for Math, the video chat. All right, one more. What shall we do? Anybody want to pick a number? Or pick some? Okay, well, actually, no, we'll just do small because you guys get all ridiculous with huge ones. 20, I don't know, let's just, again, start with a small one when you move up one, so we have another block. So let's just do something like 23 times 22. Why not? Okay, I'm gonna do it, I'm gonna draw it. You get your blocks and play. I'm just gonna draw it. All right, so, and hopefully I'll draw it in a place where you can see it. How about right there? All right, so let's see here. I need to be, ooh, can you see I'm gonna have 400 right off the bat? I hope you can. So 23 across, there's my 3 right there. And I should color code that, but I'm lazy. I'm gonna do it monochromatic. But you can, you know, get your red pen out and get your blue pen out and get your green pen out. And I'm supposed to be 20, uh-oh, that means I have another one over here. Oh, can you see the 2 groups of 3? All right, and then what? Then I have to have, so I'm supposed to be 23 across, and I'm 22 up. So that, you two guys, put my red squares in. And see, kids will get all maniacal about trying to make them, and you know what? Just get close and be fast. All right, so now, look, I'm gonna count the fast way. How many hundreds? 4 hundreds. And I'll tell you what, we'll keep track of them that way, so if you can't do it all in your head. Because I've got to do this, and then I've got to count all these. What are those? Those are 10s. So let's, and I can label them a little bit more if you want to get into it. So it's 23, that's a 3 block, that's a 3 block, so it's one of these they're counting, if you've got it built. So that's 3, 6, right? Then what's this over here? This is a 2 block, because it's 22 up and a 2 block. So let's see, there's 6 there and 4 there. That's a 10, right? Because I have 10 tens, 10 tens. And what's in the corner? 6. 506. Can you do it? Now, if you had had some practice, you wouldn't have to do it in parts like this. But I'm just saying, if you did that and the numbers were bigger and you wanted to keep track, but I can look at that and go, well, let's see, there's 4 hundreds. There they are. And then let's see here, 2 6s and 3 6s. But normally you want to count these 2 first, right? This one and then that one. Does it matter? So no, what I have there is going to be 6. And 2 is, right? So 3, 6, 8, 10 of them. All right, so now I'm up to 5, and then no 10s, as it turns out, and a 6. How hard is this? Now, you can take it and do it the other way, where you split and shift. You got your blocks, you go push them over so that these are over there, and then your little kids can fill in. And see if we can get bigger. And if you only have one set, like, you know, if this is a 7 and you only have 1 7, then this one could be a 5 and a 2. This could be a 3 and a 4, this 6 and a 1, whatever, if you were building one that was a bigger number over here. So then they could get their add-ins along with it. See, for little kids, this is math. The best way to learn math is do math. All right, so what do I have over here? Well, on this one, it's really easy. I can see I have 46. Oh, well, I'm sorry, I did it the wrong way. Wrong. 2 times 3 is 6, 2 times 2 is 4. All right, but wait, is that 2 times 2? That's 2 times 10. Or 2 10s, excuse me, 2 times 2 10s. Okay, anything over here? Nothing, because if I split it over here, there's not going to be units. Oh, look, there's 2 times 3. No, that's 2 10s times 3. So what do I get? I get 6 10s, which I just did again. And then 4. All right, so let's do it the long, slow way. And I'm taught to go this way. So 6, carry 1, that's a 0. That's it. Oh, I'm still back to 506. How hard is this stuff? Why do they make it so difficult? Why do you have kids crying in 3rd grade or 4th grade? Why do I have parents calling me up? You got to teach my kid 2 digit by 2 digit. Man, she can't handle it. She's not doing it. Why is that happening? Why have we fallen so far in mathematics that this is hard? All right. If you would like to come tomorrow, $100, 6 to 10. Next week, I'll also do another one. You can come to both, or you can come to one, $100. And then I'm going to try to record the thing. I've got a camera set up finally, and it makes lovely video. PayPal me, and we'll get this thing handled. Oh, another thing too. Well, actually, I'll make another video for that because it's at the end and nobody's going to be at the end. But my Patreon, if you guys would like to hit it for just like, they tell friends and associates and family to just go on Patreon and give me $1 for like 3 months and then quit, just to like prime the tip jar. So if people go there, they can say, oh, this guy's got a few people and maybe I'll join that. I don't know, people monkey see, monkey do. But anyway, oh, and if you do $1 and you're not in the super duper super secret math group, I'll give you an entry in there. But like I said, everybody, it's not fair for me to just let some people in. Everybody there paid. Everybody there either came to a math camp or paid 27 bucks to be there or 13 bucks to be there or whatever. So anyway, I'll put my Patreon link below, and I'm going to do another video about the Patreon thing. But like I said, just to do the Patreon, and see, then if I have enough Patreon, think about it. If I had 1,000 people give me $1 a month, that's $1,000. I can donate my time anytime, anywhere. I can just go to a school and teach in the classroom, and I don't have to worry about it. You know, taking time out of my life because I've got a, I don't know, a cushion or a base. Anyway, tomorrow, again, like I said, simple. We're gonna do it on Gmail, the video chat, and I will cover way more than just multiplication. But we'll start back and go forward, and I'll show you a whole bunch of lessons that can go with this. Because what? Well, this is just 2x plus 3 and 2x plus 2, and it's the same quadratic. And anyway, and we'll just play and have a good time. And if nobody comes, nobody comes, and that's not a problem either, because I don't miss getting up at 6 to do math and play. But I hope you guys got a little bit out of this one, and we'll talk to you soon. Crewton Ramone's houseofmath.com for more, as usual. Get over there, and there's all kinds of lessons on the multiplication page and so on. And the modules also. You see stuff in module 2, module 2, which is already teacher training, and module 1, which is the site-wide pass. And also, of course, module 3 is the site-wide pass, and module 1 has all those PDFs and the Series A manuals and stuff, and the Series A multiplication manual also talks about this. All right,